For topic two, we're going to look at factoring quadratic trinomials where a is 1, okay? First thing we have to do is look at what in the world is a quadratic trinomial. So we're going to dive a little bit deeper into this idea of quadratic, and then we're going to look at some definitions. Then I will walk you through the process of factoring. Not the hardest thing ever, but it is something that requires practice, okay? So I do want to point out, first of all, we are going to be factoring quadratic trinomials specifically where a is 1. You'll know what a is in just a moment, okay? So first of all, a quadratic trinomial is a trinomial of the form ax squared plus bx plus c such that a is not 0, okay? Now, in the previous video, I mentioned that the difference between linear and quadratic is the exponents on the variable, okay? When you're dealing with a linear equation, you have the same type of exponent, okay, or the same type of exponent. You have the same type of variable, and you have to have exponents of 1. That's what makes it linear. When you have a quadratic situation, you would have the same type of variable, so all x's or all p's or all q's, whatever. But in a quadratic, you have to have at least one exponent of 2, okay? And so that's what we're saying here. We're saying, hey, we have this trinomial. It's of the form ax squared plus bx plus c. A, b, and c are real numbers, okay? So a, b, and c can be fractions. They can be decimals. They could be integers. They could be anything, as long as a isn't 0. Because if a is 0, we would lose that x squared term, and that x squared is what makes this quadratic, okay? So quadratic trinomials are considered second degree polynomials. That exponent of 2 is really important with a quadratic, okay? Now, that's kind of what a quadratic trinomial is, okay? A is always going to be the coefficient of the squared term. B is always going to be the coefficient of what we call the linear term, just x. And then C is always going to be the constant. So in what we're going to do next, A is always going to be 1. Now, for a general quadratic, A can be anything except 0, but for us, we're only going to look at situations where A is 1 right now. Okay? Now, the next definition I have is that of factors. So factors are numbers or expressions that are being multiplied. So when we have things that we're multiplying together, we call the individual things factors. Okay? And then we have factoring. Okay? So factors are things that are being multiplied. Factoring is a process. Okay? So again, factors are numbers or expressions that are being multiplied together. Factoring, on the other hand, is the process of writing a polynomial as an equivalent expression that is the product of 2 or more factors. So this is basically the process of undoing multiplication in algebra. All right. So we're quite literally, this is sort of like an algebraic form of division, okay? You're undoing the multiplication process. So in the previous video, we looked at multiplying 2 binomials with the FOIL method. In this video, we're going to look at undoing that. We're going to take a trinomial and rewrite it as the product of 2 binomials, okay? So the factored form of a quadratic trinomial is the product of 2 binomials. So we're going to undo what we did in that first video, okay? Now, here are the steps, and I do want to point out we're specifically looking in this video at quadratic trinomials where that squared term has a coefficient of 1. So remember, ax squared plus bx plus c. A is always the coefficient of the squared term. B is always the coefficient of the linear term. C is always the constant. And in this video, we're only looking at situations where the coefficient on the squared term is 1. Okay, so how do we factor these? We already know from this statement up here that when we have a quadratic trinomial, it is going to factor as the product of 2 binomials. And in the situation we're looking at, that's the case. Okay. So what we do is we kind of set up 2 just generic binomials, and we start each of them with x or whatever the variable is. For us, we're going to look at x, okay? And then what we have to do, and this is the mathy part, this is where you have to like get some practice in. We're looking for factors of the constant that have a sum of the coefficient of the linear term. So we're looking for 2 numbers that when we multiply them, we get c, but when we add those same factors, we get b. Okay, so we're kind of looking for this like sweet spot. We have to find numbers that meet both criteria. Okay, so to complete the binomial factors from step 1 with numerical factors from step 2. Okay, so That's kind of a wordy little statement there, but complete the binomial factors from up here. Okay, that's what we're saying. So when we say complete the binomial factors from step one, we want to take the numerical factors we find from step two and fill them in here. Okay, that's going to make a lot more sense when you see this in practice. Okay, so don't freak out if the wording here is like, you're like, what? It'll make sense when you see actual examples. Okay, and then we can always check our work because we're writing a trinomial as the product of two binomials. We can check our work with the FOIL method. Okay. Now, in the event that there are no factors of the constant that add up to the coefficient of the linear term, we would just say that the trinomial is prime. Okay. So that was a mouthful. Don't get too bent out of shape about this. We're going to practice it right now. Okay. So for example 2, it says factor each trinomial. Okay, so factor each trinomial. We want to rewrite these as a binomial because again, in math, when we say factor, it's a process. There are factors that are just things being multiplied, and then there's this process of undoing the multiplication. That's what we want to do right now. We want to write this trinomial as a product of two factors. Okay, so we're going to go ahead and just start with two like dummy binomials, okay? Our variable in question is x squared, so we start each with just an x, okay? And then here's where you have to be careful. We need to find numbers that will multiply to be 8, but will add to be 9. So we just start going through and listing factors of 8. So we could use 8 and 1. We could use 4 and 2, okay? But you have to play around with your signs. Notice here, 8 is positive. So we need to find two numbers that when we multiply them, we would get a positive product. So we could use positive 8 and positive 1. We could use positive 4 and positive 2, or negative 8, negative 1, negative 4, negative 2. So when you look at each of these pairs of factors, they all have a product of positive 8. Now, which pair also has a sum of positive 9? Well, negative 8 plus negative 1 is negative 9. That doesn't work. Negative 4 plus negative 2 is negative 6. That doesn't work. 4 plus 2 is positive 6. That doesn't work. But 8 plus 1 is the magic pair. That's the sweet spot. 8 times 1 is 8. 8 plus 1 is 9. So all we do is we fill in a plus 8 and a plus 1, and we have factored it. Okay. And then the cool thing is we can always check our work with FOIL. So check. So we have x plus 8 times x plus 1. So we would start the FOIL process. So I'm going to take x times x, that's x squared. X times 1 is just x. I'm done with the x in the first binomial. I'm going to pick up the 8. 8 times x is 8x. 8 times 1 is 8. And then I'm going to clean this up. I'm going to simplify and write it in standard form. So I drop down my x squared. And then x plus 8x is 9x. And then just drop down my 8. And so notice this right here is exactly what we started with. Okay, so we can say that we've checked our answer, and our factored answer is officially 8x plus, not 8x, x plus 8 times x plus 1. Okay, let's try this again. Okay, so for part B, we have x squared minus 7x plus 12. Okay, so since our variable is x, we want to start two binomials, each with an x. That way, when we FOIL, we'll get x times x, which is that x squared. But for the other two factors, we need to look for factors of 12 that add to negative 7. Okay, so notice the constant negative 12, it is positive. So when we look for factors of 12, they have to have the same sign. They're either both going to be positive or they're both going to be negative. So we could have 1 and 12, negative 1, negative 12. We could have 2 and 6, negative 2, negative 6. We could have 3 and 4, or negative 3, negative 4. In each of these 6 pairs of factors, if we were to multiply them, we get positive 12. But we need to find the one pair that will also add to be negative 7. Okay, so 1 plus 12 is 13. That doesn't work. Negative 1 plus negative 12 is negative 13. That doesn't work. 2 plus 6 is 8. That doesn't work. Negative 2 plus negative 6 is negative 8. That doesn't work. 3 plus 4 is 7, so we're getting somewhere, but remember, we need it to add up to be -7. This adds up to be +7, so it doesn't work. And then finally, -3 times -4 is +12, and -3 plus -4 is -7. So this right here, that's our sweet spot, okay? So we just want to fill in a -3 and a -4. It does not matter which binomial you put which factor in, just make sure the sign in front of the factor is correct. So x minus 4 times x minus 3 would be perfectly fine, okay? So this right here is our final answer, and if you want to check it, you can. We can check with multiplication. We can do the FOIL method. So we have x minus 3 times x minus 4. So we would take x times 4, or x times -4 rather, -3 times x, and -3 times -4. And then when we simplify it, we get our x squared minus 7x plus 12. And that's it. So you can check your answers here very easily to see if you have factored correctly, okay? So let's look at part C and D. All right. So part C, we have x squared plus 3x minus 28. Please know that in all 4 of these examples, the coefficient of the squared term is 1. We did that by design. If the coefficient of the squared term is not 1, it's a different process. Don't worry about those. I'm not going to test you on that. Okay. So for us, we've got x squared plus 3x minus 28. We want to factor this, and we know quadratic trinomials factor as the product of 2 binomials. So we're going to start our 2 binomials, each with an x. That way, when we start the FOIL method to like multiply this out, we would get that x squared term. Now, for the other 2 terms in your factors, you need numbers that multiply to be -28 and have a sum of +3. So notice our constant is a negative. So when we look for 2 factors of 28, one must be positive, one must be negative. So we could try -1 and +28, or 1 and -28. We could do -2 and 14, or 2 and -14. 3 won't go in, 4 will go in, so we could try -4 and 7. We could try 4 and -7. And I think that's it. Those are all of our factors. So we've got all the factors of -28. So each of these 6 pairs, if you multiply them, you get -28. Now we got to find the one that adds to be +3. So -1 and 28 is 27. That doesn't work. 1 and -28 is -27. That doesn't work. -2 and 14 is +12. That doesn't work. 2 and -14 is -12. That doesn't work. 4 and -7 is -3, so we're getting somewhere. That one's close, but again, we need +3, not -3, so that one doesn't work. And this one right here, this is the sweet spot. -4 times 7 is -28, but more importantly, -4 plus 7 is that +3. So this is the pair that adds correctly and multiplies correctly. So we would want to go +7 minus 4. You could also put the -4 first, the +7 second. It does not matter. Just make sure the sign in front of the factor is correct when you go to put it in the binomials. So this is our final answer. And again, just for the sake of practice, we can check this. So we have x plus 7 times x minus 4. X times x is x squared. X times -4 is -4x. 7 times x is plus 7x, and 7 times -4 is -28. And then we can simplify these 2 middle terms. So in standard form, we get x squared plus 3x minus 28, which is exactly what we started with, okay? So notice the answer here is the stuff that I've highlighted in yellow. The stuff below that is where we're just checking our work to make sure everything matches, okay? So last up, we have x squared minus 2x minus 15, all right? This is a quadratic trinomial where the coefficient on the square term is 1. This will factor to the product of 2 binomials, each starting with an x, okay? Now, to find the other 2 terms in these binomials, we need to look for factors of -15. So numbers that when we multiply, we get -15. This means one must be positive, one must be negative, and then those 2 factors have to also add up to be -2. So we could try 1 and -15 or -1 and +15. We could try 3 and -5 or -3 and +5. And I think that's it. That's all the different pairs of factors that add or that multiply to give us -15. So now we have to find the magic pair that adds up to be -2. So 1 plus -15 is -14. That doesn't work. -1 plus 15 is +14. That doesn't work. -3 plus 5 is 2. So that's close, but it's the wrong sign. We need -2. So finally, we get 3 plus -5, and those add up correctly. So that's the sweet spot. All right. So 3 times -5 is -15, and 3 plus -5, that's our -2. So we want to go +3 -5. And just remember, the binomial that you put your factor in, it doesn't matter. It doesn't matter where you put the +3, where you put the -5. Just get each of them in one of those binomials, okay? So if I had written this x minus 5 times x plus 3, that would be fine. All right, you can hear my dog snoring in the background, sorry. So let's check our work. All right, we have x plus 3 times x minus 5. So we get x times x, which is x squared. X times -5 is -5x. 3 times x is 3x. And then 3 times -5 is -15. We want to combine like terms. So I get x squared minus 2x minus 15, which is exactly what we started with. Okay, so you do need to make sure that you can factor a quadratic trinomial where a is 1. Okay, if a is something other than 1, we have a different process for those. Okay, so in the next video, we're going to start looking at quadratic equations. Okay, we have not looked at equations yet. These have all been expressions or just polynomials. They didn't have an equal sign. So when we get down here to topic 3, we'll start looking at quadratic equations, and we'll look at one method for solving them. Okay, so I'll see you back in that video in just a bit.